Hello everyone. So today we will learn about the topic 13, thermal analysis. Linear thermal conductions or the convection problems are formulated using the finite element approach with temperature as a single degree of freedom variable at each node in mesh and with the material conduction properties used to form the thermal stiffness matrix to be solved. ANSYS Workbench includes capability for modeling many types of thermal and thermal stress problems of interest to practicing engineers. The temperature distributions found at each thermal analysis node can be used with the equivalent structural model as inputs for finding stresses caused by temperature changes. So, important terms used in thermal analysis. Transient thermal analysis determine the temperatures and other thermal quantities that vary over time. Many heat transfer applications involves transient thermal analysis such as heat treatment problems, electronic package design, nozzles, engine blocks and pressure vessels. So we are going to see about the types of thermal analysis. ANSYS support two types of thermal analysis. A steady state thermal analysis determines the temperature distribution and other thermal quantities under steady state loading condition. A steady state loading condition is a situation where heat storage effects varying over a period of time can be ignored. A transient thermal analysis determines the temperature distribution and other thermal quantities under conditions that vary over a period of time. So we'll take the example of the car disc brake rotor. So we are going to do the analysis on the same in a practical way. So how does it work? A disc brake consists of cast iron disc, rotor bolted to the wheel hub and a stationary housing called a caliper. The caliper is connected to the stationary part of the vehicle like the axle casing or the stub axle as is cast in two parts, each part containing a piston. In between each piston and the disc, there is a friction pad held in position by retaining pins, spring and the plates. Passages are drilled in the caliper for the fluid to enter or leave each housing. The passages are also connected to another one for bleeding. Each cylinder contains rubber sealing ring between the cylinder and piston. So this is how the disc brake work. Here you can see the piston and the caliper as mentioned in the upper slide. This is the wheel on which the hub is attached, which is also called as on the hub the rotor is attached of the wheel. So we are going to see this problem in a practical way on ANSYS Workbench. So we are going to first set the data for the material. We are taking structural steel as the material for our project. So as I have already created the geometry and you all know how to create the geometry, I am directly moving forward with the model. So this is the rotor disc. So in this, first of all we have to check for the materials. Then next we have to do the meshing. So click on mesh, click on generate mesh. Now here you can see our meshing is done. Here you can see. Now we have to apply steady state thermal conditions. For that we have to apply the temperature condition on the base. So I will select this face to apply temperature and we'll apply the temperature as 22 degrees centigrade, but here the temperature is in Kelvin. So we are going to change the units from Kelvin to centigrade and we have to apply it 80 degrees centigrade as a temperature. Now we have to apply the convection. So for that go to environment and apply the convection. So convection we are going to apply for the internal body. So click on face. Click on apply. So for the film coefficient, we are going to take it from the temperature dependent tools. So we are going to taking stagnant air as a default film coefficient for the rotor. Click on OK. Okay, in the tabular data you can see the convection film coefficient. Now in the solution we add the temperature change for the entire body and temperature change for the outer side of the surface of the rotor. Click on apply. Now click on solution, click on solve. Now solution is done. We'll see how the temperature varies. So minimum temperature is 76.49 and maximum temperature is 80 degrees centigrade. We'll see in an animated way. So now here you can see. So this is how temperature varies from base to the upper side. Now we'll see for the outer surface of the temperature variations. So minimum temperature is 77.276 and maximum temperature is 78.673. So it varies from here to the base of the rotor.